Good afternoon and welcome to Mass Talker online class. In this video, we'll be talking about Charles' law. Okay, Charles' law states that the volume of a given mass of gas is directly proportional to temperature. Don't forget, in Boyle's law is inversely, but in Charles' law is directly proportional to what? Temperature in Kelvin. That temperature must be in Kelvin, provided that the pressure, okay, and number of mole remains constant. This means that when the volume of a given mass of gas increases, that the temperature increases as well. Then if it decreases, that the temperature decreases. So let us represent it mathematically. Right? Mathematically, we say that what? That the volume of a given mass of gas is directly proportional to temperature, provided that what? That volume and that pressure remains constant. Okay, pressure and number of mole remains constant. So we now have that V is equal to what? KT. All right. So if you make K subject of formula, you now see that K is equal to what? V over T. So you now call it V1 over T1 is equal to what? V2 over T2. So this is Charles' law. Okay. Where, don't forget, where V is equal to volume, okay, T must be equal to what? Temperature in Kelvin. Please, you must put that this temperature is in Kelvin, okay? Then K is equal to what? Proportionality constant. Proportionality. Okay, so that is that. Well, now let's solve some question to illustrate that. Okay, proportionality constant. All right, so I now have that the first question said a fixed mass of gas. Number one, a fixed mass of gas, a fixed mass of gas with an initial temperature of 546 Kelvin is subjected to heat and allowed to expand. Okay, then I said if the final temperature is 819 Kelvin, okay, what is the ratio of the final to initial volume? Okay, final to initial volume if pressure remains constant. Okay, so this is very, very simple. They gave us the first temperature, T1. T1 they say is 546, and T2 they gave us is what? 819. They are all in Kelvin. Okay, so no need to convert. But we know that what? V1 over T1 is equal to V2 over what? T2. Now they want us to find the ratio of the final to the initial. So they mentioned the final first. So this man will come down, they will now exchange, so that I will have final up, the one mentioned first up, while the one mentioned second will now be down. So I will now have that what? T2 over T1 is equal to what? V2 over what? V1. Are you getting it now? So what do we have now? My T2 is what? 819 over what? 546 is equal to V2 over V1. So what do we have? If you reduce it to the lowest, you will have 1 up, 1.5 here, and then I have 1. Okay, so which is equal to what? V2 over V1. So therefore V2 is to V1 is equal to what? 1.5 is to 1. All right, so that is the ratio between the final to the initial. But if it's the ratio between the initial to the final, it will not be 1 is to 1.5. All right, okay. So the next question The next question said a sample of nitrogen, number 2, a sample of nitrogen gas occupies 117 cm cube at 100 degrees Celsius. Then I say at what temperature in degrees Celsius would it occupy 234 cm cube if the pressure, okay, and number of mole remains constant. If pressure and number of mole remains constant. Okay, now let us get our parameters. The first parameter they gave us is volume. That V1 is equal to 117 cm cube. And then T1, the first temperature is 100 degrees Celsius. Please, never you leave your temperature in degrees Celsius. It must be in Kelvin, because they say that what? The volume of a fixed mass of gas is directly proportional to temperature in Kelvin. So my temperature must always be in Kelvin. Degrees Celsius plus what? 273. That is how to convert to Kelvin, which is what? 373 Kelvin. All right. So they gave us V2 as what? 243, and then T2 is unknown. All right. So solution, from here we will now have our formula that say that what? V1 over T1 is equal to V2 over T2. So if you substitute everybody, we will now have that V1 is 117 all over T1. My T1 is where is my T1? My T1 is 373 is equal to what? V2, my V2 is 243 all over T2 is T2. So if you cross multiply, you will now see 117 T2 is equal to 243 times 373. So therefore my T2 will now be 243 times 373. Everybody divided by 117. So my T2 will now be what? If you divide, you will have that T2 is 746 Kelvin. 746 Kelvin. But they say we should get our temperature in degrees Celsius. So to get it in degrees Celsius, my T2 will now be 746 minus that same 243. Okay? If you want to take it back, you subtract. If you want to take it to Kelvin, you add. So if you subtract this, you will now have that your answer is 473 Kelvin. 473 degrees Celsius, 473 degrees Celsius. You see, this is a very simple something to do. So don't forget that in Charles' law, that your temperature must always be in Kelvin. So number 3 question, they say that at 25 degrees Celsius and 1 atm, 1.0 atm, all right, a gas occupies a volume of 1.50 dm cube. Okay, they say what volume will it occupy at 100 degrees Celsius and 1 atm, okay, pressure, and number of mole being kept constant. All right, so this is a very simple something to do. Now, since the pressure is the same, it means that the pressure is constant. Since the pressure is the same, it means that the pressure is constant. But they gave us the first temperature as 25 degrees Celsius. You must convert it to Kelvin, which is what? 25 plus 273. What do you have? 25 plus 273. Where is it? That is 298 Kelvin. All right. So now T2, the second temperature they gave me is 100 degrees Celsius, which is what? 100 plus 273, which is what? 373 Kelvin. But they gave us the first volume. The first volume they gave me is 1.50 dm cube. So they are not asking us the second volume. V2 is unknown. So since my V2 is unknown, so what do we do? The pressure are the same, like I said. And if the pressure is the same, it means that the pressure is kept constant. Constant means does not change. It doesn't change. We have the same thing. So we know that our formula for Boyle's law, our Charles law said that what? V1 over T1 is equal to V2 over T2. So put everybody, you have V1 is 1.5 all over T1 is 298 is equal to what? V2 is unknown all over T2, which is 373. So if you cross multiply, you have V2 times 298 cross multiply is equal to 1.5 times 373. So my V2 will now be 1.5 times 373 divided by 298. So my V2 will give me, if you divide that, you will have 1.87 dm cube. All right. So you see that these questions are very, very simple. Once you know your formula, it's very, very simple. All you need to do is to know your formula. So question number 5 said a gas sample with initial volume of 3.25 dm cube is heated and allowed to expand to 9.75 dm cube. All right. Then I said at a constant pressure. Then I say what is the ratio of the initial to the final absolute temperature. Okay, the initial to the final absolute temperature. You know that absolute temperature is temperature in Kelvin. So, but we don't need that. So they gave us that the first volume is what? 3.25, and the second volume is what? 9.75. So they want the ratio between the final to the initial. Okay, sorry, which one they mention first? Initial to the final. So if they mention initial first, then this one should go up. The one mentioned first will always be up. Then this one should come down. So I have V1 all over V2 is equal to T1 over what? T2. So if you now put everybody, you now have that T1 over T2 is equal to my V1 is 3.25 divided by 9.75. So I have that what? T1 over T2 is equal to what? 1 over 3. So I have 1 over 3. So therefore T1 is to T2 is equal to 1 is to 3. All right. So that is that. Very simple. So now let's talk about the graphical representation of Charles' law. Graphical representation of Charles' law. Graphical representation of Charles' law. Graphical. So graphical representation of Charles' law, we have that we have our volume to our temperature. Temperature must be in Kelvin. Okay. Temperature must be in Kelvin. And then I have my volume. I have my volume here. Okay. If the temperature is in Kelvin, then it will pass from the center here. But if the temperature is in degrees Celsius, if the temperature is in degrees Celsius, temperature in degrees Celsius, and then I have my volume, okay, then it will now be, here is minus 273. Then it will now start from here, getting to this place, and then move up. Okay, so that is how it is. Then the next one is when it is inverse. So if you have V over T, you know, V over T is your proportionality constant. If you have your proportionality constant against the temperature in Kelvin, okay, then it's going to be a straight line like this. Okay. So the next thing is that if you have the fourth one, if you have log, is in log, if you have your log V, and log T, okay, then it will just be like this. Okay, so that is the graphical representation of Charles' law. Okay, so now the next thing you write is now how kinetic energy, how kinetic theorem explains Charles' law. How kinetic theory explains Charles' law. All right, so write for me. Assuming a given mass of gas is enclosed, like the way we did before, is enclosed, okay, or confined in a vessel using a suitable piston. If the gas is heated in order, if the gas is heated, in other words, if temperature of the gas is increased or raised, the particles of the gas acquire more kinetic energy and collide more faster. In other words, the pressure of the gas increases. All right, the pressure of the gas increases in order to maintain or keep the number of collision constant. That is, to keep the pressure constant, the piston will be raised up, thereby making the volume of the gas to increase. Therefore, at constant pressure, the volume of the gas increases as the temperature increases. For instance, if the temperature of the gas increases from T to T1, then the volume will increase from V to V1, provided that the pressure and the number of collision remain constant. Right? So, like we did before now, let me explain. If you put a gas in something now and start heating it, because of the fact, maybe it's like this, for instance, now, watch. We place it in something like this, like we did before, right? Now, we have this now, and then we now put heat. Okay, if we heat this thing now, let's say we apply heat here. If we heat this thing now, the more you are heating it, the more they want to escape. They are heating themselves, bubbling everything, which will now increase the pressure. Okay, so if you increase the temperature, the pressure will increase. And then if you don't want the pressure to increase, if you want the pressure to remain the same, then you have to move this thing up. You have to increase the volume. So if you increase the volume, then it will now keep the pressure constant. So that is what is showing that what, as you apply heat, if you apply heat to it, then what happens is that it will increase in volume. It will now increase in volume. Are you getting it now? So that is it. Don't mind my drawing. All right. So that is what Boyle's law is explaining. So the more you apply heat, the more the volume will increase. So provided that the pressure is constant. Okay, provided that the pressure is constant. So the next one we'll now look at in the next video is Amontons law of pressure. Amontons law of pressure. Let me check my time if I'm going to just do that here. Okay, so let's just do it here. Amontons law of pressure, or pressure law anyways, is called Amontons law. A-M-O-N, Amontons law, or we call it pressure law. Pressure law, right? All right. Amontons law states that at constant volume, now remember Boyle's law said at constant temperature that volume is inversely proportional. Okay, then Charles' law said at constant pressure that volume is directly proportional. Then pressure law, which is Amontons law, is now saying that what? At constant temperature. So always know the one that is constant. Okay, so at constant temperature, that the volume of a given mass of gas is directly proportional. Sorry, at constant volume. At constant volume, that the pressure of a given mass of gas is directly proportional to the temperature. Okay, which means, in other words, you can just state it that what? That the volume of a given mass of gas, sorry, not volume. Volume is the one constant. Amontons law mathematically, all right, state that you start from that pressure, that the pressure of a given mass of gas is directly proportional to temperature. Even I explained it that if you keep applying more light, they want to escape, they are fighting each other, so it will increase the pressure. So as you are increasing the light, the pressure must increase. So that's why he says that what? That the pressure of a given mass of gas is directly proportional to temperature, provided that volume remains constant. All right. Don't forget, let me recall Boyle's for you. If it is Boyle's law stated that what? It started from volume, that the volume is inversely proportional to pressure, provided that temperature remains constant. Then for Charles' law, he said that what? The same volume is now directly proportional to temperature. Pressure is the one that is constant here. Then for pressure law, which is Amontons law, said that it started from pressure is directly proportional to temperature, then volume remains constant. You see the way they are. So if I now remove proportionality sign, I will now bring in my proportionality constant. So which says that my K will now be what? P over T, which says that what? My P1 over T1 is equal to my P2 over T2. Powerful formula. Where what? Where my P is equal to pressure, my T is equal to what? Temperature in Kelvin. Please, that's the mistake I made. That the pressure of a given mass of gas is directly proportional to temperature in Kelvin. Please, temperature in Kelvin. Okay, why my K is what? Proportionality constant. Proportionality constant. All right, so let us now solve some questions to illustrate that. All right. Please, anywhere you see temperature in gas laws, always remember to put it in Kelvin. Please, very, very important. Always remember to put it in Kelvin. Please, very, very important. All right. So question number one said a bicycle tire pumped in the morning at a temperature of 23 degrees Celsius. In fact, an example of Charles' law, we say that the volume is directly proportional to temperature, which means if temperature increases, that the volume will increase. Is if you remember when you do play football, there's this football that is called bladder or something. Okay, if you put that football outside, maybe it is lessened. If you put it outside where sun will hit it, as sun is hitting it, if you now come back to check, you will now see that it is now very strong. What is pumping it is because of what? Increase in temperature will bring about increase in pressure. But because they don't want the pressure, they want the pressure to remain constant, it will now be bringing increase in volume. Are you getting it now? So that is it. Even it equally explains this one self. So that is it. So they now said a tire at 23 degrees Celsius has a pressure of 210 millimeter mercury. Okay, then I say what is the final pressure? What is the final pressure of the tire if the temperature rises to 54 degrees Celsius? Okay, then they say if the volume of the tire remains constant. They say if the volume the volume of the tire remains constant. Okay, solution. So from here, let us bring out our parameters. The first parameter we have is that they gave us the first temperature T1, and T1 they gave us is equal to what? 23 degrees Celsius. And I told you, please always keep it in what? In Kelvin by adding 273. So 23 plus 273 will now give us what? 296 Kelvin. All right. So the next thing they gave us is pressure P1. P1 is 210 millimeter mercury. Okay. Then they now gave us T2. T2 they gave us is what? For 54 degrees Celsius. 54 degrees Celsius, which is what? 54 plus 273, which will give us 327 Kelvin. So they are now asking us P2. P2 is unknown. So we know our formula that said that what? That P1 over T1 is equal to P2 over T2. So what do we have now? My P1 is 210 all over 296 is equal to my P2. My P2 is unknown all over what? 327. So if you cross multiply, you will see that 296 times P2 is equal to what? 210 times 327. So therefore, my P2 will now be 210 times 327 divided by what? 296. So if you do that, you will now get that your pressure is now 231.9 millimeter mercury. All right. So that is very, very simple. So we move to the next question. We move to the next question. Question number two said a car tire pumped in the morning has an initial pressure of 145 millimeter mercury. Then I say if the final pressure of the car tire after a long drive rises to 725 millimeter mercury. Then I said, what is the ratio of the final to the initial temperature if volume of the tire remains constant? Okay, so solution, this is very simple. They gave me the first pressure. The first pressure P1 is equal to 145 millimeter mercury. And they gave me P2, which is equal to what? 725 millimeter mercury. So since they are asking me the ratio, I still know my formula that what? P1 over V1 over T1 is equal to P2 over V2. So I have my, since they say the final first to the initial, so the final is going to come up. The final, the one mentioned first, will always be up. So I have T2 over T1 is equal to this one. They will just swap. So I have what? P2 over what? P1. So I have that my T2 over T1 is equal to what? My P2 is 725 over 145. So if you divide, you have P2 over T1, T1 over T2, I'll be 2 over T1 will now give you, what do we have? 1:5. Okay. So I now have 5 is equal to what? 5 over 1. So what do we have? That T2 is to T1 is equal to 5 is to 1. Okay. very, very simple. So let's solve the last question on this, and then we'll now move to ideal gas equation. Okay, let's solve the last question and then we'll move to ideal gas equation. Right. So I have number 3 said a bicycle, B-I-C-Y-C-L-E, a bicycle tire checked before use at a temperature of 57 degrees Celsius has a pressure of 270 millimeter mercury. Then I say what will be the temperature, in degrees Celsius if the tire pressure rise if the tire pressure rises to 310 millimeter mercury. Very simple question. All right. So now the first thing they gave us, T1 is what? 57 degrees Celsius, which is what? 57 plus 273, which will give you 330 Kelvin. It must be in Kelvin. So the first pressure they gave me is 270 millimeter mercury. And the second pressure they gave me is 310 millimeter mercury. Now let us find our second temperature, T2. So T2 is unknown. Okay, so my P1 is what? 270 over T1, 330, is equal to P2, 310 over T2. Leave it as T2. So cross multiply to have T2 times 270 is equal to 310 times 330. So therefore my T2 will now be 310 times 330 divided by 273. So therefore my T2 will now be, if you do the calculation, you will get 378.9 Kelvin. So but they say we should do it in degrees Celsius, which is T2 will now be 378.9 minus 273. So which will now give you 105.9 degrees Celsius. All right. So that is that. So the next thing we'll now look at is general gas equation before the ideal gas equation. So let me check my time. Okay. So thank you very much for watching. Please like, share, and subscribe. Bye-bye.